Hello, welcome to this session on using the discriminant to find missing coefficients using the number of real roots. Now, there's the quadratic formula, so we'll take a step back, think about this. And a very important part of that is the square root bit. Now, the part under the square root, b squared minus 4ac, is called the discriminant. That tells us the number of roots. So you can read this bit of information here about it. So pause and maybe have a look at this, and then I'll explain. Okay, so if you've got a quadratic equation or quadratic function, you can tell in the form ax squared plus bx plus c how many times it goes through the x-axis, or if it's equal to 0, how many solutions there are. Now, if b squared minus 4ac, if that's greater than 0, we've got a number which is more than 0, and we'll have two square roots, a positive and a negative. Therefore, there'll be two distinct solutions to the equation of that equals 0, of this equals 0, and we get two real roots. If it's equal to 0, the discriminant, then the square root of 0 is just 0. So there's just one repeated root. And if it's less than 0, well, conventionally using real numbers, we can't take a square root of a negative number. You get complex numbers in that case. We have no real roots. We're going to have a look at that with some graphs to see what that really means. Okay, as promised, let's look at the graphs. At the top, you've got your positive a, so the coefficient of x squared is positive, hence the kind of smiley shape. Your unhappy shape here is when a is negative, so it goes up and down. Here, your discriminant is positive, so that means when you square root it, you've got two different values. Hence, the quadratic equation can give you two solutions, two distinct roots. So you've got to kind of, in your head, link this shape to this. This is all from the Pearson textbook. Very good, very useful, very good reference. Now here, the discriminant is exactly 0. Square root that, you just get one value. So that's why your quadratic equation gives you just one solution. And it just touches the graph there, one repeated root. Here, if you get a negative value for the discriminant, it's below 0. You can't square root it to get a real number, so it can't go through the x-axis. These are the key points you need to know. Okay, so find when the equation x squared plus kx plus 16 equals 0 has equal roots. Well, let's think, what does that mean? That means that the discriminant must equal 0. So I know b squared minus 4ac must equal 0 because there's equal roots. I can go back and look at my rules just to verify that, and that's what I'm looking for. So what's b? Well, b is k. b is the number in front of x, minus 4, lots of a is 1 because it's just 1x squared, times c, which is 16. So I just substitute that in. K squared minus 64 equals 0. So k squared equals 64. K is positive and negative 8. So it has equal roots when either k equals 8 or negative 8. if I put in 8 or negative 8 in place of k, that equation would have equal roots. It would just, if you drew a graph of it, it would just touch the x-axis. And we can tell that because the discriminant is equal to 0. That's how you would answer a question like this. Find when the equation 3x squared plus 2x plus k has two distinct roots. Well, two distinct roots means the discriminant has got to be greater than 0. So b squared minus 4ac is greater than 0. I've got to have a positive number I can square root to get two different values. Let's put the values in. B is 2, so I've got b squared, 4, minus 4 times 3 times k. 4ac is greater than 0. 4 minus 12k is greater than 0. So let's say 12k must be less than 4. So k must be less than 1 over 3, 4 over 12. So I know when k is less than 1 over 3, this equation here has two distinct roots. So I could put in any value here that's less than a third, and I know it would have two distinct roots. If this is greater than a third, then it wouldn't. So when we see when does this equation have two distinct roots, we put the discriminant greater than 0 and we solve the inequality. Now here are some to have a go at. This is an exercise I got off the TES website, and I'd just like to credit whoever Tumshi is because they put this on, and this is, I thought, a really good exercise. You've got the answers on the next page I'm going to show you, so you might want to pause and have a go at these. It would be a really useful exercise. If you want to pause before I give you some hints, then do so. Well, here are your hints. Here has real roots where you want the discriminant to be greater than or equal to 0. So for this one, I would say, okay, discriminant greater than equal to 0. Has no real roots for 2. Discriminant has got to be negative, less than 0. Here, real and distinct roots. That means the discriminant can only be positive. It wants just two distinct roots. Number 4 has real roots greater than or equal to 0. And number 5, no real roots, less than 0. There's hints. So you pick out the discriminant and then you form the inequality you want, and you've got your problem. Okay, well, I'll go put the answer. Okay, there's your solutions, of course, in the form of inequalities. I hope they're clear. Now, remember, there would be method marks for these in an exam. If you can't quite get them, go back, have another go. Thank you very much.